408 valid word abbreviation. So this question is giving a string of word and also a string of abbreviation, and trying to let you to tell whether the abbreviation can validate this word. Let's take an example. To say this word, and that it has I12, IZ4N. The first character is lowercase English char, and the second for the abbreviation, the same thing. So so we can iterate for the next characters. Let's say for the next character it is N, but for the abbreviation it is a number. So for next one, let's say there is a 12 after I. So for the first string, we can skip 12 characters. And here, go to the next character, find the same, it is I. And that is, after that, there is a Z. So after Z, there is a 4. So we need to skip 4 characters. And the last one is N. So we'll say both string has been iterated to the end, and then we'll say this abbreviation can validate the word. This question is marked as easy, but actually to do this question, it is kind of tedious, or a lot of corner cases you need to care about. For example, we cannot the number, it can be 0, but we cannot have a number like 03. This kind of number will be invalid. So if we have this kind of scenario, we'll say it's not a correct abbreviation. And of course, we can have a pointer which point to the abbreviation string and iterate it one by one. If it is English lowercase character, we just trying to see whether it has the same character with the word. And then if this number, we use a number variable to find this number. So the first code, as I mentioned, the first corner case is the number. We cannot have something like a 03 or something like that. This is not correct. And after we get a number, then we can skip this number of the characters in the word and compare the next. And the problem is that here I have the I variable. I iterate from an abbreviation from the index 0 to the end. And I have a J variable which starts from the word. And it is there is another situation is that possibly I have an I, for example, 1000, and A. Let's say this will be a very large number, and after J, for example, go to I, go to the first go to index 1, and then I get 1000. J goes to N, that is also index 1. It plus 1000. It already exceeds the word length. In this case, it will also be a incorrect valid abbreviation, so it will return false. And also, we want to make sure at the end, for example, we have an I10, and I iterate this and finish the abbreviation string. And I want to make sure because it ends with a number and J is still in an index. It's not end to the end of the word. And we need to make sure that left part is exactly this number. So we'll return the J plus number equals word dot length. So let's write code for this. Firstly, let me change this one to cherry. And I'm going to have two variables. One will be the index, which is pointing to the word, and another will be index, which will pointing to abbreviation. At the beginning, they are all at 0. I'm going to have a number variable, which will, for example, will record those kind of number. For example, this will be 12. And when I iterate to I will clear this number to be 0. So put this one as 0. So let me iterate I. Let's get the length out into a. So y j. That's it because we are going iterate the abbreviation. Yj smaller than m. I'm going to have firstly is that if this is a char, it's digit. If this is digit, but do something. And if it's not digit, that means this is the char. So basically, if it's digit, we need to calculate this number. But there is a corner case, as we mentioned, this number, we cannot have the number to be like a 0, 3 or this kind of format. So we write a corner case here. If array with num equals to 0 and array j equals this, we are return false. else we just have this number equals number multiplied by 10 plus 3 minus 0. Make sure we put a parentheses here. So this is if it is a number. So we compare when this character goes to lowercase English char, we will have this number. So we put the logic here. Firstly, so we'll say I will plus equal to this number, and we'll clear this number to be 0. And we have one condition that is, for example, this number is a very large number. If I is already greater or equal to a, will return false. And after that, we need to compare this because this abbreviation, this character is a lowercase English. So we could say if word array dot I doesn't equal to abbreviation array dot j, we just return false. And after this, we for both I index and j index, we can move one forward. And here we're right here, and there is another corner case is that it's possible that we have a 10, a number at the end, and for the first for the word, we may still iterate, just iterate here, and when we finish the while loop, so we finish the while loop. Now I is still at this position, and we need to make sure there are exactly 10 characters after that from the last position. So what we return is not I equals a, not, but it should be I plus number equals to n. So we'll return this value. So we return I plus number equals n. This is not C, it's A array J. Oh, why there is time limit exit. Oh, here. For this kind of index, we still also need it to be moved forward, so that there is a number, we'll get the number. So let's submit the So for this, we use pointers to iterate the string in the abbreviations. So let's say um, the abbreviation, the length is m. We'll say the time complexity is OM, and the space complexity. Actually, I converted this to array, uh, but you can also use the string char at I or char at j. So I'll say the space complexity this depends on how you calculate. So it's also OM plus n.